In this lesson, I'm going to show you how to complete the next step in working with linear equations, in which we'll be evaluating linear equations. In the problems for your homework that you're going to do related to this topic, you'll have to do both the writing portion and the evaluating linear equations all at once in the same problem. But for the sake of time in this lesson video, I'm just going to give you the equation that I wrote based on the situation and then show you kind of how to evaluate it. Because it's really important to be able to figure out some information regarding the equation we wrote. And this is kind of a really useful tool. So with our situation here, should be familiar. I just took this from the final pages in your blue notes that were on writing linear equations. And so this is the evaluating portion. So Jack is mowing lawns for a summer job, and remember it costs a certain amount per day to rent the lawnmower, plus $3 for every gallon of gas that he uses. And so in another lesson video, I showed you guys how to write the equation, which I have right here. So I showed you how to write the equation that represents the cost of renting the lawnmower for one day, the cost of using the lawnmower after a certain amount of gas, okay? So $3 times every gallon plus the $25 he has to spend every day just for renting the lawnmower. So what we're going to focus on today is this last sentence right here where it says, what is the cost of renting the lawnmower for one day if he uses 4 gallons of gas? And again, this is math class, so I'm going to look and circle my number 4, and it's for what? 4 gallons of gas. Okay, so gas is the variable we're looking at. We're looking at using 4 gallons. So we want to know what's the cost if he uses 4 gallons. Now I've got this equation right here that I'm going to kind of rewrite below. So C equals 3G plus 25, right? That's the equation we have that represents this, or models this particular situation. And so somewhere, I've got 2 variables here, right? I've got a C, which is normally like our Y, and I've got a G, which is normally like our X. And one of them, I have to put in the number 4. I'm going to plug in the number 4 into one of those pieces. And I say I'm going to choose G for gas, right? Because G was what represented gas. So I'm going to replace where I see where I see G, I'm going to replace it with a 4. Remember, when a number and a variable, so 3 is my number, G is my variable, are next to each other, what's happening between them? Well, multiplying, right? That's like saying 3 times G. There's multiplying happening between those two guys. So here's how I rewrite this. I'm going to say the cost in total, which is what we want to know, equals 3 times whatever G is, which we decided G was the 4, right? We're going to replace it with 4 gallons. So say we use 4 gallons, how much is it going to cost? Plus 25. And now I just need to evaluate. I'm going to bring my C down, right? Because we want to know what C equals. We're saying, hey, what does C equal? Let's do order of operations. I've got multiplying and adding. Multiplying comes first in PEMDAS. 3 times 4 is going to get us 12. And then bring down my plus 25. Now all I need to do is do 12 plus 25. And that's going to get me 37. So C equals 37. So that means the cost is $37. Best practice here is to actually write my answer and rephrasing the question. So it's a word problem, so my answer requires a word answer. So I would say the cost of renting the lawnmower if 4 gallons of gas are used, or if using 4 gallons of gas, or if Jack uses 4 gallons of gas, is $37. I'd be totally fine and I'd accept the answer if you just wrote C equals $37. I just want you to connect it back to the problem and include the $sign. So the cost of renting the lawnmower if 4 gallons of gas are used is going to be $37. And we could figure out exactly how much it would cost for any number of gallons of gas that we decided to use. So that's kind of cool. Now that we've written a linear equation to model this situation, we can find out, hey, if I maybe used up 15 gallons of gas, which is a lot. You'd never do that mowing lawns, hopefully. But you could see how much it would cost you. And then you could decide, hey, am I going to make any money off of this? Okay, let's look at the next situation here where we've got a negative slope. So in this particular case, we're measuring how thick the ice sheet is over Bear Lake. And as you can imagine, as spring goes on and the weather gets warmer, the ice sheet starts to melt. And so what happens to the thickness of the ice sheet? Well, it goes down, right? Okay, and so what we want to know, well, sorry, back up really quick here. I've got the equation modeled right there, as you can see. Watch the other lesson video if you want to know how to do that. And we want to know after how many weeks will the ice sheet be completely gone. Uh-oh, this particular one doesn't have a number that they give us directly, does it? It just says after how many weeks will the sheet be gone. So this is where you have to ask yourself, how thick is the sheet? So how thick is the sheet if the ice is completely gone? What numerical value could we use to represent the fact that the ice sheet is entirely gone? Well, if you think about it, if the ice sheet is totally gone, it's 0, right? 0 inches. So that's the number we're going to be plugging in, is going to be 0. So we want to know how many weeks have gone by once we've gotten to 0. So again, I'm just going to copy the equation that I've got right here. T equals, so it decreases by 4 inches per week, so -4 times W, right? Decreasing, so that's why it's negative, plus the 48 inches of my starting point that we started at, which we can see right up here. Where were we? 48 inches thick is where it starts. 4 inches per week is how much we're decreasing. Okay. Now I need to figure out, is the 0 going to go in for T or going to go in for W? Now, it's a little easier when you're doing this all together at once, because if you remember, step 4 is to define the variables when we're writing equations. And so when we defined the variables for this particular one, I said T equals thickness and W equals weeks. Or we could also say the time as time goes on. Okay. And now I need to decide, is the 0 going in for the W, is 0 going in for T? And we're used to plugging in for our input, right? We're used to plugging numbers in for the X value, which in this case would be W rather than T. But remember, the 0 inches stands for how thick the ice sheet is, right? How thick. How thick is the ice sheet if the ice is totally gone? Well, it's 0 inches thick. So what that means is that we actually want to plug in the 0 for T, because we want to know, when is T going to equal 0. So the solving process for this one's a little more difficult. I think I only have 1 or 2 problems on the homework today that will require you to solve them like this, where you're plugging in for the output value instead of the input. But where I see a T, I'm going to put 0. So 0 equals -4. And just for the sake of clarity, I'm going to write my time symbol, times W. Right? We're still not replacing anything for W, but I'm just separating these guys out a little bit so it's more obvious that multiplying is happening. And then bring down my, let's get black there. And then plus 48, plus the 48 inches of my starting point there, 48 inches thick. Okay, so what I'm trying to do now is I want to get W by itself on one side of the equation, right? Because I want to solve for the variable W. So let's say I'm going to want W to be on the right side of my equation, just because it's already on that side. And so let's move all the mess of numbers over to the other side. So if you remember, it's easier for me to move the 48 over first, because the -4 is super close to the W. It's hard for me to undo multiplying. It's a lot easier for me to undo adding. So let's move a positive 48 to the other side by subtracting 48 from both sides. So if I subtract 48 from both sides of the equation, on the left side there, I've got 0 minus 48. 0 minus 48 is going to get me a -48. I just bring down my equal sign there. Bring down my -4 times W. And we could have left that as -4W as well. That would be totally fine. -48 plus 48, what's really nice about that is they cancel out, right? That's 0. So we can see we're starting to simplify a little more. W is almost by itself on that side of the equation, but now I need to move that -4 somehow. I need to move that -4 over to the other side of the equation. And so what I'm going to ask myself is, hey, what's going on? Well, it's -4 times W. How do I undo multiplying? Well, I need to divide. So I'm going to divide that side of the equation by -4, and I'm going to divide that side of the equation by -4. It's really useful right here that we're actually getting rid of our negatives, and you'll see why in a second. So on the left-hand side, negative 48 divided by a negative 4 is actually going to get us a positive 12. Bring down my equal sign. Negative 4 divided by negative 4 equals 1, right? So it's kind of like they canceled out. So I have 1w, which is good. We just want a single w by itself on that side of the equation. And finally, we can read the equal sign either way, right? So we could say 12 equals w or w equals 12. So what I want to do, just so it looks clearer and cleaner, is I'm just going to rewrite, put w first. Say w equals 12. So how many weeks? 12 weeks. So see, that's where it's really nice that we ended up dividing a negative by a negative, because we can't have negative weeks, right? The ice sheet isn't going to melt in negative 6 weeks, for example. It's going to melt in positive 6 weeks. So that's why it's nice that we ended up with being able to divide a negative by a negative so that we get a final answer that is entirely positive. So again, word problems require word answers, rather. So how many weeks until the ice sheet melts all the way completely? 12 weeks. So it's kind of cool at that rate. We can estimate about when will the ice sheet be completely gone. So in answering our question, after how many weeks will the ice sheet be completely gone? We could say after 12 weeks, according to the situation we've modeled here, the ice sheet will be completely gone. So you just have a few problems today to work out that are kind of like this. Some of them they all require you to write and evaluate the equation at the same time. And then some of them require you to answer a few more questions based on your evaluation of the function. Okay? But feel free to zoom in if you have any questions. Thanks for watching.